I'm Masahiro Aoki, founder of the OpenCI. I was working at IBM Japan as a software engineer, and I was startup CTO and co-founder for 3 years. And I really love Flutter very much and had experienced it for 5 years. And I'm based in Tokyo, Japan. But why do I love Flutter? Flutter is open source software, source framework by Google. And if you write one code, you can save it to many platforms like iOS, Android, web, Linux, macOS, Windows. Yeah. And what is CI/CD? CI/CD has 2 parts: the continuous integration and continuous delivery, CI and CD. And typically, in Flutter, you will pull the source code from the GitHub and do a static analysis and the unit widget end-to-end test. And if the previous step succeeds, you can go to the next step, continuous delivery. And in this step, you make a build and deploy it to your platform, like Firebase app distribution, test flight, and App Store Connect. But why does CI/CD matter? The short answer is speed. The most important factor of the CI/CD is that it boosts your development speed. So as I said, CI/CD is beneficial for all developers. However, there is a big problem for CI/CD for Flutter. It's pricing. So there are 3 major CI/CD for Flutter. As you see, the pricing is really complex. It isn't easy to budget. Most of them are not fixed price. Pay as you go. So it means that the more you code, the more the price goes up. For example, even though the bill of the first month is $100 US, but when there are many bugs and write a lot of code and create a lot of PR and more builds were needed, this leads to higher pricing. Maybe in the next month, the price will be doubled, maybe tripled. So due to this pricing system, it was challenging to me to introduce CI/CD when I was a CTO. And I think other companies and other developers have the same problem with the CI/CD for Flutter. So CI/CD for Flutter isn't affordable, accessible to small startups, companies, indie developers, and junior developers who are eager to learn CI/CD. CI/CD improves development speed, but only rich organization can afford CI/CD for Flutter right now. So in short, CI/CD for Flutter is not open to everyone. So I have decided to create OpenCI, CI/CD for every Flutter developers. So our improved pricing is like this. We offer free CI/CD for all projects, including private repositories. And we also offer up to 4 concurrencies. I think it's enough for most of the projects. And the CPUs are M1 Apple Silicon, so your build for iOS is fast enough. And if you need more CPU power, concurrencies, maybe the paid plans would be available. But how do we achieve this lower pricing? First, we use Taoto to create a VM, macOS virtual machine. Before WWDC 2022, it wasn't easy to create a macOS VM, so we didn't have many options to use. Anchor was one of the few options. However, the license of the Anchor is very expensive. It's around a few thousand US per year per Mac. And due to the Apple license, Apple allows us to launch macOS VM at the same time, at most 2 per Mac. But at the WWDC 2022, Apple announced a virtualization framework to create a VM more easily. Taoto is an open source project by CI. It offers here the interface. It's really easy to create a macOS VM, and the fee is almost free. Most of the CI/CD providers rent Macs from Mac providers like AWS, Mac Stadium. This costs a few hundred to $1,000 US per month per Mac. At OpenCI, we don't use Mac providers. We self-host Macs. More specifically, we buy second-hand Macs and broken Macs, sometimes donation from other developers. For the donation, a few weeks ago, one of my Japanese clients told me that his MacBook Air M1 was broken by the beer can, and it exploded in his backpack, and the beer was I bought as a souvenir from London. Unfortunately, this one, the left side, the MacBook, the display was broken like this. However, the CPU works fine, so we can treat it as a build machine. How does OpenCI work? I'll show you how OpenCI works with code base. So first, OpenCI is open source. Everyone can contribute this. And most of the codes are written in Dart, which is for Flutter. And of course, I could choose other languages like TypeScript, Go, Python, Ruby, and so on. But OpenCI should be open to every Flutter developer. And if your OpenCI was written in other languages, it becomes very difficult to contribute for junior to mid-level Flutter engineers. So most of the engineers, including myself. And Jenkins is a great tool for the CI/CD. However, it is difficult for junior to mid-level engineer, including myself, to understand, so we don't use it. We have decided to write a system from scratch with R. I will explain how to fetch build jobs. We use Probo framework, which is OSS project to create the GitHub apps easily to get new build job. And the GitHub apps are similar to GitHub Actions. We use Probo Firebase admin and the UUID as import. Since we use Firebase admin for accessing Firestore, UUID for creating a unique ID for Firestore's document ID. These are the triggers of the Probo. This means that when pull request is opened, we open synchronized, the Probo starts processing. This initializes Firebase admin SDK. We use Firebase service account JSON to also authenticate user. In this step, we write OctKit, a wrapper library of the GitHub REST API. It is very useful when using GitHub REST API. The last line fetches an installation token of GitHub. This token acts like a GitHub personal access token. So we authorize GitHub and clone source code and put it to the macOS VM. When the trigger fires, the Probo add a build job to the Firestore like this. And then listen to Firestore document changes. When the build result changes, like processing to failure, processing to success, it will update the Firestore document. If the build succeeds, it will also add an issue comment to the pull request with the build number for users to find the right job at the Firebase app distribution. The next step is Firestore to OpenCI runner. We use very good CLI by very good ventures to create an OpenCI runner. With these commands, you can create a great CLI app instantly. These are the packages we use for OpenCI runner. The first 4 packages come from very good CLI. They provide CLI compression, update, and logger. And .firebase admin SDK for admin is for accessing database, Firestore as an admin. And .ssh2 for establishing SSH connection, and process learn for running shell script. To use OpenCI runner, you need 2 arguments. The first one is a Firebase project name, and second, the service account JSON of your Firebase. So you need to create Firebase project, and it's free. And you can self-host OpenCI. The first step is initializing Firebase project to use Firestore API with service account JSON. And then create a loop to find a new job from Firestore. When the OpenCI runner finds a build job, we prepare a virtual machine. First, clone the VM from the original image and run it. And after that, fetch the IP address of the VM, and then SSH to the VM. This demo shows how easy it is to launch a VM with a single command. This step creates a Firebase service account and several files to build IPA APK file from base 64 data at Firestore. then import them to VM. If the build succeeds, distribute it to the Firebase app distribution for physical device testing. Internally, this method calls Firebase CLI. We have these tasks to tackle right now. Dashboard and supporting of the multiple flavor schemes are coming in a few months. After that, we support uploading the build to Play Store, Test Ride, App Store Connect. Within 2024, we want to make Android build faster with Docker and make the initial setup faster. And in next year, we want to support cache for faster build. Future plans of OpenCI. And in the future, we'd like to utilize unused computers. A few weeks ago, I was cleaning one of my client's office. I found an unused MacBook Air with an M2 chip, and I asked the CEO why. And he told me that the Mac was used by an employee who recently quit his startup. I have 3 clients right now, and all of them only have at most 10 employees. However, 2 of them have unused Macs. This implies that there are a lot of unused Macs in the world. We also find unused Macs in the offices around the world during non-working hours. If we utilize these unused Macs, we could provide CI/CD for many more developers. And I think this is environmentally friendly and sustainable for us and yours. There will be many problems like security, internet speed to achieve these plans. However, if we provide the same interface as cloud provider using unused Macs, the internet becomes less expensive, more open to more people. And special thanks to Maru Yamamoto. She helped me organize this presentation and gave me a lot of valuable insightful feedback. Thank you very much.